It begins with a perfect golden ring. This iconic shape is nature's toughest armored fruit, dismantled and reassembled with sub-millimeter precision inside a high-speed industrial ballet. Inside this facility, 100 tons of tropical fruit are processed every single hour. It is a billion-dollar logistical operation where biology meets heavy mechanical engineering. The journey starts here, on plantations spanning thousands of hectares. This is a race against time, beginning the moment the fruit reaches its peak biological maturity. Unlike bananas, pineapples do not ripen after picking. Once harvested, they immediately begin to ferment. The entire supply chain is a high-stakes race against spoilage. Science dictates the harvest. Agronomists use refractometers to measure Brix levels, the exact sugar content, in the field, ensuring only perfectly sweet fruit enters the processing chain. While factories are automated, picking remains a manual art assisted by massive machines. A 50-foot boom conveyor assists workers who harvest with synchronized speed. The fruit travels along the boom, transitioning immediately from the plant to the logistical network. There is no downtime. The flow of product must be constant. The conveyor deposits the fruit directly into transport trucks. A single truck holds 20,000 pineapples, and the factory requires a new delivery every 15 minutes. Loaded trucks form a continuous steel river connecting the field to the factory. The logistics network is designed to minimize the time the fruit sits idle in the tropical heat. At the factory receiving bay, the scale of operation becomes clear. Trucks arrive on a precise schedule, backing into hydraulic lifts designed for rapid, high-volume unloading. To unload 20 tons instantly without bruising the fruit, high-pressure water cannons flush the pineapples from the truck into a water-filled receiving pit. The fruit enters the flume system, water highways that gently transport the pineapples while simultaneously beginning the cleaning process, removing field dirt and debris. An inclined conveyor lifts the fruit from the flumes, passing them under high-pressure shower jets for a final, thorough cleaning before they enter the mechanical sizing zone. Automation requires uniformity. A diverging roller system mechanically sorts every pineapple by diameter. This is crucial because the peeling machines are calibrated for specific sizes to minimize waste. Once sized, the fruit travels on dedicated lanes. Each lane feeds a specific bank of machines calibrated to process that exact diameter, ensuring maximum yield from every fruit. This is the heart of the operation, a bank of legendary Ginaca machines. These engineering marvels revolutionize the industry, enabling the processing of 100 fruits per minute. The machine's intake is synchronized to the millisecond. Mechanical claws grab each fruit, centering it precisely to ensure the coring blade travels perfectly through the middle. In a violent fraction of a second action, a high-speed, rotating cylinder plunges through the fruit. It simultaneously cuts a perfect cylinder of flesh while ejecting the central core. Simultaneously, the tough, spiky outer skin is stripped away by a set of curved blades, separating the usable flesh from the agricultural waste in a single motion. What emerges is a perfect, uniform cylinder of pineapple flesh, the diameter standardized to fit precisely inside the eventual can. The transformation from spiky fruit to uniform product is complete. Even with advanced automation, the human eye is essential for quality control. Skilled workers inspect the rapidly moving cylinders, manually trimming any imperfections the machines missed. High-speed optical lasers scan every millimeter of the fruit's surface, detecting discolorations or remaining shell pieces. Imperfect fruit is instantly blasted off the line by precise jets of compressed air. The flawless cylinders are reoriented and fed into the slicer. This machine features a gang of rotating blades spaced perfectly to create slices of uniform thickness. In a blur of rotational cutting, the solid cylinders are transformed into the iconic pineapple rings. The spacing of the blades determines whether they become thick or thin slices. Not every slice is perfect. Broken rings are automatically diverted to a secondary line to be chopped into chunks or tidbits, ensuring maximum usage of the fruit flesh. Meanwhile, in the syrup kitchen, precision mixing tanks prepare the liquid medium. Depending on the product, this ranges from heavy sugar syrup to plain native pineapple juice. The canning line begins with pallets of empty containers. A magnetic robotic depalletizer lifts entire layers of cans, feeding them into the high-speed filling network. Before a single piece of fruit enters, every can is inverted and blasted with high-pressure steam and hot water, ensuring a sterile environment for the product. Volumetric fillers drop the exact weight of fruit into each passing can. The speed is mesmerizing, filling hundreds of cans every minute with consistent accuracy. A cascade of hot syrup fills the remaining space in the can. This liquid medium preserves the fruit's color and texture during the intense cooking process that follows. The filled cans pass through a steam exhaust tunnel. This raises the temperature and drives out trapped air bubbles, which is crucial for creating a vacuum later. At the seamer, a crucial trick of physics occurs. A jet of live steam is injected the instant the lid is applied. When the steam cools and condenses, it creates the vital vacuum seal. The sealed cans enter a massive continuous cooker. Inside, they will be subjected to high temperatures to achieve commercial sterility, killing bacteria and deactivating enzymes. Inside the retort, the cans are heated to over 100 degrees Celsius. This neutralizes bromelain, the enzyme that would otherwise turn the fruit to mush, and ensures long-term preservation. Emerging from the heat, the cans are subjected to immediate thermal shock, plunging into cold water canals. This stops the cooking process instantly, ensuring the fruit retains its firm texture. High-velocity air blowers dry the cans completely. Removing all external moisture is vital to prevent rust from forming on the metal during storage and shipping.
Under high-velocity air nibs, the air jets shear the water droplets off the can surface in seconds.
Every can passes through a dud detector that checks lid tension. Cans without a proper vacuum seal sound different and are instantly rejected from the line. Before labeling, the bright cans are palletized and sent to a quarantine warehouse. They rest here for 7 days to ensure stability before final packaging. Nothing is wasted. The nutrient-rich cores ejected by the Ginaca machines are diverted and crushed in industrial presses to extract concentrated pineapple juice. The tons of tough outer skins are shredded and dried in massive kilns. This material is converted into high-fiber pineapple bran, a valuable feed for the livestock industry. After quarantine, the cans return to the line. High-speed rotary machines apply labels using hot melt glue, processing up to 600 cans every single minute. The cans are grouped and drop-packed into corrugated cardboard cases. The entire case erection, filling, and sealing process is automated, requiring no human intervention. Heavy-lifting industrial robots build the final shipping pallets. They stack the cases in precise, interlocking patterns to ensure stability during global transport. The finished pallets are shrink-wrapped for security. Automated print and apply systems attach the final shipping manifests, destined for ports around the world. The journey is almost complete. Forklifts load the finished pallets into shipping containers, connecting the high-speed factory floor to the global supply chain. From a muddy tropical field, the fruit has been transformed into a sterile, shelf-stable commodity, ready to travel thousands of miles to supermarkets on other continents. The next time you crack open a can, remember the journey. It is a triumph of agricultural timing and industrial engineering. It is a process defined by speed, precision, and the legacy of a century-old invention that turned a spiky tropical fruit into a global staple. Safety is invisible but paramount. In the on-site microbiology lab, technicians incubate random samples from every batch, searching for any trace of spoilage organisms before the product is released. Chemistry determines longevity. The lab monitors the pH balance of the syrup and fruit. If the acidity isn't perfectly calibrated, the preservation process will fail. Machines handle the volume, but humans judge the taste. A sensory panel tastes samples from every shift, grading the fruit on color, texture, and flavor profile. Many megafactories are vertically integrated, manufacturing their own cans on site. It starts with massive coils of tin plate steel, unrolled and fed into high-speed body makers. Flat sheets are cut and rolled into cylinders. A high-speed copper wire welder fuses the side seam instantly, creating a continuous stream of metal tubes ready for flanging. The smooth cylinders are beaded, given those familiar ridges. This isn't aesthetic. It adds structural integrity, preventing the can from imploding under the intense vacuum pressure of the retort. The juice pressed from the cores and skins enters massive vacuum evaporators. Here, water is removed to create a thick, high-value pineapple concentrate used in sodas and sauces worldwide. The concentrate is packed into aseptic drums. This shelf-stable liquid gold is a major export commodity in its own right, shipping to beverage manufacturers globally. When production pauses, the clean-in-place systems take over. Every pipe, tank, and belt is flushed with caustic soda, acid, and hot water to sterilize the lines for the next next day. The Ginaca blades must be razor sharp. In the maintenance shop, machinists grind the cutting heads daily. A dull blade crushes the fruit cells, leaking juice and lowering the yield. Preventative maintenance is constant. Mechanics patrol the line, lubricating gears and replacing bearings. A single seize bearing can halt the entire 100-ton-per-hour operation. Sustainability is now a requirement. Liquid waste and sludge are pumped into anaerobic digesters. Bacteria break down the organic matter, producing methane gas to power the factory. The methane from the digesters helps fire the massive boilers. These generate the tons of steam required for the peelers, the exhaust boxes, and the retorts, closing the energy loop. Water is a precious resource. The factory treats and recycles millions of gallons, purifying the flume water to be reused for washing raw fruit or irrigating the nearby fields. High above the floor, the control room acts as the brain. Operators monitor real-time data, adjusting conveyor speeds and temperatures to balance the flow between intake and packaging. The factory is a major economic engine, employing thousands of locals. The facility runs 24 hours a day during peak harvest, with shifts rotating in a seamless cycle. From this remote location, the supply chain reaches out to the world. Logistics managers track containers in real time, ensuring the pineapple arrives in time for holidays in Europe and America. Months later, and thousands of miles away, the can sits on a shelf. To the consumer, it is a simple convenience. To the engineer, it is a miracle of preservation. Whether it's a controversial pizza topping or a classic upside-down cake, the fruit retains the exact texture and sweetness it had the moment it met the Ginaca machine. Speed, precision, volume. The modern pineapple factory is a testament to how far food technology has come from the days of hand peeling and spoilage. It takes a synchronized army of farmers, drivers, engineers, and machine operators to overcome the natural decay of the tropics and deliver fresh fruit to the world. It started as a spiky, armored tank in a muddy field. It ends as a perfect golden circle. This is the high-speed automation of the pineapple.